On problem 5, we're given a situation with some farm crops. We're supposed to represent the situation with a system of equations and then solve specifically for corn using Cramer's rule. So the first thing we want to do when approaching a system like this is identify our variables, our totals and relationships, and our descriptors. Our variables are the 4 types of crops that we're working with. Our totals are total amount of acres, total amount of money spent. We're given a specific total just for pumpkins, and then we're also given a relationship, and that's that the acres of soybeans have to be double the acres of wheat. We also have some descriptors to go along with some of the individual crops, and that's how much each of them cost. And so all of that information is going to be grouped together in the equation that we set up to show the total amount of money. And so since we've got 4 totals and relationships, well, 3 totals, 1 relationship, that gives us a total of 4 equations altogether that we need to write. So our first equation will show the total amount of crops, and there's no extra descriptors needed there, so it's just the variables by themselves added together, and that gives us total acreage. The next rule with the total amount of money, that's where we do need those descriptors. We have our relationship that the soybeans have to be equal to double the acres of wheat. And then the final equation showing that just pumpkin by themselves have to be 700 acres. Now when you're setting up a system like this, you want your variables to line up vertically, and in this case with the third rule, S equals 2W, that's not the case. And so we need to tweak that rule a little bit so that we can get all the variables on one side and the constants on the other side. So I subtracted W from both sides, and that left me with 0 on the right hand side. And so now I have an equation that's got constants on one side, variables on the other side, and I have it written in the same order as all my other equations. So I made W show up first and then S show up second. Now that we've got our system set up, we can go ahead and figure out what our coefficient matrix looks like. When we're working with Cramer's rule, that's a ratio of the determinants of 2 matrices, where the matrix on the top is the coefficient rule replaced by the constants in the row of the variable that you're solving for, and the determinant on the bottom is the determinant of just the coefficient matrix by itself. And so, again, determinant of the coefficient matrix goes in the denominator, and then we're solving for corn, so we need to replace our first column with the constants in our equation, and then everything else in the top matrix is going to match what we have in the bottom matrix. At this point, it's a matter of putting the information into your calculator to figure out what those determinants are. And these are the values that I got, which gave me a total of 3,625 acres of corn. Problem 7 is a systems of inequalities problem. We're given some limitations to work with. We're given some variables to work with. I know the ones that we did in class were not set up in this way where the table was given that already had the information organized, but the problem on the test today will have a similar type of table to help with the organization. And so similar to the last problem, we need to identify variables, and then we need to identify totals, or in this case our limits. And so we've got 2 variables in this situation, and that's high school rings and college rings. And then we've got 3 limitations that we're working with. 1 for molding, 1 for engraving, and 1 for polishing. And so we're going to end up writing 3 inequalities that go with each of those limitations, and all of our inequalities will have the 2 variables, a variable for high school, a variable for college. We can kind of fill the information in the table since it's already organized in the way that we need to organize our inequalities anyways. And so here's what our system will look like. So the first inequality shows a limitation on molding, second inequality shows limitation on engraving, and third inequality shows the limitation on polishing. And each one of those inequalities includes both variables for H and for C. Next thing we need to do is to get a graph in order to show where the feasible region for this system will be. And the easiest way to sketch graphs of all three of these, since they're written in standard form where the variables are on the same side of the inequality sign, is to find the intercepts. And so in each case I set h equal to 0 and solve for c, and then set c equal to 0 and solve for h. And that gives me 2 points that I can plot on a graph. And so there's my, what will eventually be my x and y intercepts. And at this point, when you sketch your graph, you have to make the decision of which variable you want to have on which axis. For all of my coordinates, I listed the h variable first, which means that my high school rings are going to be on the x-axis and the college rings will be on the y-axis. So now I'm going to sketch my graph. Finding the intercepts first allowed me to figure out what my scale should be. The biggest number out of all those intercepts was 250, so I figured as long as I counted up to 250 on each axis, then I would have enough room for all of my points. Now I can go ahead and sketch all my lines. And in this case, if we use 0, 0 as a test point, it makes all of the inequalities true. Our goal is to stay underneath all those limits, and so our feasible region is going to be the region that lies underneath all of those lines.